Welcome, everybody. Shit, we got a full room today. Really cool to see. Really cool to see. My name is Daniel Yuschick. Thank you all for being here and enjoying the last day of the conference together. I want to give a shout out to Build Stuff for letting me be a part of the event this year. This is my first time being here, first time in Vilnius and Lithuania as a whole. So really excited to be here and just as excited to be talking about probably my favorite part of the front end, which is componentization. First, if you'd like, you can go ahead and download the slides ahead of time. This will give you a couple extra sections that we're not going to have time to cover today. So you can kind of get a little extra bonus from there. It'll take you to a PDF on Dropbox, so that's all good. While you do that, I'll introduce myself. Again, my name is Daniel Yuschick. I've been working in the front end for about 15 years now. My first job was as assistant webmaster, if that gives you any idea of how old I actually am. Assistant to the webmaster. I began as a designer, and I've taken that eye for design, UI, UX, and a passion for accessibility, and moved that into my current position, which is as lead design systems developer at SAP. So despite the accent, I am American, but I do live in Helsinki, where I do some volunteer work with a coding school called Hive Helsinki, and a nonprofit called CodeBar Helsinki. So I think we have a few people watching online from those organizations today. So what up, y'all? Thank you for joining. Yeah, so that's enough about me. We're not really here to learn about me. We're here to learn about component stuff. So our goals for today are to identify component patterns in our UIs that tend to break down over time, and then alternatively, learn approaches that may be a bit more resilient to that change, because content will forever and always change. So how do we build our components and our UIs to be resilient to those changes? We're going to do this by looking at two key sections. First is going to be how do we manage our TypeScript interfaces for our components? And then we're going to look at a React convention as well on how we can approach building components to create a bit more flexibility within our UIs. Again, if you downloaded the slides, you're going to get a couple extra sections built in here, but this is what we'll cover today. I think the TypeScript stuff is quite universal, regardless of what framework and stuff you might be using. The React stuff might be a bit specific to it, but maybe people who use Vue and Angular and stuff might know, well, they would know better than I would if there's an equivalent approach. So that's our goal for today. That's what we're going to look at. I think we can just go ahead and get started with our interface management and how do we make the most out of our component APIs. We're going to look at three keys in this section. The first one, we're just going to dip our toes in the water a little bit, have a nice little easy intro here. That's just going to be grouping similar props. Now, one thing I want to note is that unless I specify otherwise, every code sample we're going to see here today is taken from a live production code base. I've worked a lot of jobs. That's what developers kind of do. I grabbed these code samples from stuff that was actually live in production at that time. So we're going to see real life examples of how some of this stuff tends to break down over time. And that brings us to our input component. This is a subset of a, like I said, real life production interface that I've come across. And I want to focus on these 5 specific props that we have. They relate to label types, themes, sizes. We have 5 value props in our interface. So what happens if we want to add a new size or add a new theme? This interface is going to keep bloating with that. Every type of variant or value that we add to this input is going to extend and grow and bloat this interface. And it becomes very difficult to manage over time, and even harder for a new developer to come into it, or just a person who hasn't worked on it for a year to come back into it and figure out what's going on. So instead of having props specific to a component's values, we can have these props specific to a component's categories. So we can instead have props relating to the label, the theme, and the size. So if we do this approach, we get an interface that is much cleaner and much more extendable by having props specific to a component's categories and not the component's values. Then we're able to use TypeScript union types in this case to create values that are much more extendable. So we have the different sizes and themes and stuff in here. But now, if we want to add a high contrast theme for some accessibility, or we want to add an extra small size, we just extend the union type in TypeScript. Our interface doesn't bloat. Our interface doesn't change. And then we learned that if we just type size or theme into our component, normally our code editors are going to autocomplete or auto-suggest the options to that prop. So I'm sure the IntelliJ talk previously would have been able to highlight that much better than I can. But we have fewer props we need to know, fewer props we need to remember, and then we can let the autocomplete kind of show us the suggestions, and we're able to add values and extend an interface without really complicating it or bloating it. We can see this with buttons as well. In this example, again, we have button shapes and variants, and we have our sizes and stuff. So we're able to apply this category concept of grouping props into categories. We're able to apply this across components, and we're able to see how these values can be extended and used in different situations. So the same thing that applies to the input can apply to the button, because it's easy to think of a component as a small thing that will just always stay a small thing. It's like the people who bought the little teacup pigs, not knowing that the cute little pig was going to grow into actually a big pig, right? Components can grow and become more complicated over time, and if we have an interface that can account for those changes and account for that growth, we can create more resilient interfaces and components. There's another way I like to look at this to kind of, classic analogies, how to drive the point home that something can start small and become very complicated over time. I like to look at New Kids on the Block as a start. Wonderful, brilliant, made their mark. So much so that Take That and Westlife came about. I mean, we even got Robbie Williams banners outside the hotel right now coming to Vilnius to perform. This then led to Backstreet Boys and NSYNC, probably my personal favorites. And then this led to the flurry of 98 Degrees, LFO, and O-Town, and a whole lot more that, frankly, tough to find GIFs. So they didn't quite make it to that level, I guess. That later went to One Direction, Liam Payne, and then to BTS, who took over the world. Now, we may have started with New Kids on the Block and thought, okay, this is a small, self-contained, isolated thing. But before we know it, we have a very complex, wide, deep network, in this case of boy bands, or in terms of props and stuff for our components. Now, to be fair, I don't think this is a bad example. I think this is actually a good thing to have happened. But we have more TypeScript stuff that I think is a lot worse than boy bands. We have this concept here, or this approach with our input, where we have an error message, and then we have a has error Boolean prop. Now, I couldn't really find a good term for this on Google or in ChatGPT, but I like to refer to this as a data gate model, where we have the error message, which is the data that we want to present typically within the UI, and then we have the Boolean gate. Now, in our JSX, again, we're going to be looking at some React stuff. We might use this as, hey, if has error is true, render the error message prop, change some styles and class names on the input, all that stuff. But what we're kind of doing here is having two props for specifically one value. There might be instances where you have a tooltip message and a has tooltip prop. You might have hint and has hint prop. You're effectively creating two props for one piece of data. So I think a different approach that you can have for this is to remove the data gate and just have one single data gate prop. I think we can trust that if we have an error message prop and it has a value, probably means that we have an error. I think we can kind of trust that. So we can use this where we use the double bang to see if error message is truthy. Maybe within the component we can assign this to an internal has error const or something like that. But I think when we just use the data prop itself, we're able to again keep an interface from growing, from becoming very complex, very bloated, and difficult to manage. We're able to simplify our interface to one prop, and we can just check for that prop's value. So we want to be able to group our props into categories, and if we have multiple props referring to the same thing, we can group that as well. And that is how we want to group similar props in our interfaces. So that's our first key that we want to look at, which brings us to our second key, which is consistency is key. I was going to say that this is probably my favorite key, but the next one is also my favorite. This is the stuff that I super, super enjoy. I love talking about this stuff. I love working on this stuff. This is why I'm in design systems, because my job is to define these patterns, define these conventions, advocate for them, document them. This is the stuff I get really, really excited about. So everything we're covering today is equal parts my favorite. I love this stuff. And this key here about consistency, yeah, this one near and dear to my heart. The main point that I want you to take away today, even if this is the one thing you take away from this talk entirely and just zone out the rest of the time, is that if you know how to use one component, you should know how to use the others. If you know how to use one component, you know how to use the others. Now, we're going to look at an example here with a button and a switch. They both have similar conventions where you can both show loading states, they can both show disabled states, they both have sizes. But they're each doing them in different ways, different conventions, different patterns. And this is very, very, very common to see. Like I said, developers, at least me, change jobs a lot. So it might have been I built the button component, I go somewhere else, a new dev comes in, they build the switch component, and either I haven't documented the conventions for them to follow, or I did, and they just want to follow their own process anyway with the intention of refactoring later. You might have a component library or a design system, but no dedicated team to work on it. So other teams might just contribute back to that whenever they see fit, and there's, again, no real governance of how the components and those conventions are used. So this is very, very common. These samples were taken from the same code base. This is an example of how both of these things can live side by side and does happen over time. But we can avoid this by ensuring that we're using the same naming conventions across both our props and our values in our components. So we've taken that same button component and that same switch component, but we've also added in an icon component here, just to show that these conventions don't just apply to controls and interactive elements, but to visual icons in this case as well. So now we have the same consistent isBusy pattern, isDisabled pattern, and all of our sizes are the 2-letter t-shirt size convention. It doesn't matter what your convention is. It just matters that your one convention applies to all of your components. So even though this icon has an extra small size to it, and the button and the switch do not have extra small, you can make a pretty reasonable guess that if you need an extra small size in this icon, it's probably going to be XS, because that's the convention used for everything else on every other component. But this also applies beyond just prop names and prop values. We also want to apply consistency to our defaults. If you have the same prop on our button, our switch, and our icon, we have the same size prop, we want to make sure that they have the same defaults as well. So if I use the button and expect its default size to be medium, I'm going to expect the switch's default size to also be medium and the icon's default size to be medium. I've been in code bases where that's not the case, and it gets pretty confusing when you have to write a size prop or not. So when we have just one set of conventions, we can learn those, and it doesn't matter if we're learning the components because the one set of conventions applies across the board. Another way to say that is that we're not learning the components. We're learning the conventions. If you work in a component library or maybe a larger design system, you might have 30, 40, 50 components. If those are using different approaches, different conventions, different patterns, that's a massive learning curve to step into and to understand and to become proficient at using. The whole goal of having these component libraries and design systems is to, well, I guess, 2 goals: enforce branding, but also ensure developer experience, efficiency, and productivity. If we are breaking those conventions and you have to learn the individual components, that efficiency and productivity, down the drain, it's gone. So we want to make sure that we're learning the conventions that apply to all the components and not the components themselves. So when the library adds another component here and there, and you go to 40, 50, 60 components, those same conventions apply, and you can use that shared knowledge as the system grows. Now, I am a developer But I come from a design background. That's why, as a design system dev, I work on the design team. I'm part of the design team. Because this consistency goes beyond just development and code. It extends to the design side as well, and it requires that collaboration and that communication across teams. So here we have an example. Now this is one that I made up just to fit this narrative. So this is all my code just to do this. But we do have a button next to an input in sizes from small, medium, large. Now I would expect, if we have this consistency on the code side, that this is going to create a consistent UI as well. Then if our code is consistent, our UI as a result should also be cohesive and consistent as well. And this is where that collaboration comes into play. We're not just building components for the developers. We also have to make sure that these components are in sync with the design as well. So when you have these conventions shared across teams and you collaborate, you can create a UI that is a bit more consistent. You can expect that if you put a small button next to a small input, that's going to create a cohesive UI. If you have a pretty lengthy form and you have input fields, text areas, select menu, radio buttons, you have all the different types of controls. If you define all of those as a size medium, you should have a very consistent form in the UI. And this takes that collaboration, it takes that communication, and you have to make sure that that consistency that we strive for in our code also extends to consistency in the design in the UI. At the end of the day, we're ultimately building trust amongst teams and throughout our product. So it strives for consistency on both design side and development side. Which does bring us to our final key for interface management. Spoiler, also my favorite. Don't reinvent HTML. HTML has been around for decades. A bunch of people have been working on it, all of which smarter than I am. Why am I going to try and remake these nuances and remake these features in my own half-baked kind of way? Every time that we deviate from HTML within our components and within our interfaces, we create one more nuance that we have to remake and relearn. We have to remake it on the dev side, and we have to relearn it on the implementation side anytime we're trying to use this component. So every deviation from HTML is one more thing we have to remake and relearn. We're going to pick on the input component again here. So let's say you start a new role, new product, new job. Maybe this is all the design calls for. You have an input with just a few different states. So you create an interface with these few props, and you think, great, success, we did it. Our interface and our component now support the designs that are required. But then 3 months, 6 months down the road, designs change. Content will forever and always change. Now we need different input types. We need different input sizes. We need input slots for different content and stuff like that within this one input. So our input component now has a lot more requirements to manage, because again, it's accounting for all of our content. So we might do something like this. Okay, technically, we're getting there, we're making it, things are working, everything's fine and dandy until it isn't. And then you end up getting this. A reminder, code samples we see here, unless otherwise specified, are real existing production code samples, including that thing. I stepped into this code base, brand new dev, brand new person to the team. I see this. Tell me why. Why does this exist? How did we get here? Right? And I think one way that we can look at this is we want to make sure that whenever we're creating our interfaces, we're separating HTML attributes from our own component props. We want to treat attributes and props as two separate things. Our props should be custom to our component and manage the component itself. Attributes should just be HTML. I imagine everyone in this room touches the front end at some point. Otherwise, you'd probably be in another talk. We should all know HTML. I think there's an issue generally with the industry where we prioritize JavaScript. That's a whole other discussion to have, but we should all know HTML. And if we all share that understanding and that knowledge, we can leverage that when building our components. We don't have to recreate that. We can just leverage the fact that people working on the front end already know HTML. And now our inputs and elements can support that already. So if we go back to our input field and we revisit that interface, we're able to use TypeScript to extend the native HTML attributes. And by doing this, we have access to all those types, all those placeholders, the RE invalids, all those attributes that we would expect to have on our input field. We don't have to recreate them and put them on our interface ourselves, because eventually that's going to bite us. Eventually we're going to need a type that we don't support. Eventually we're going to need an attribute that we do not support, and then we have to go through and edit the component itself. It becomes a lot. But instead, we can just leverage TypeScript to extend those HTML attributes, have that native support. And now, just as we're writing HTML to use our components, we can use those attributes that we know and are familiar with and work the way we expect them to. Another example of this is probably top 3 most common issues I find entering a new code base. And it's always the button, and it's always a text prop. I mean, sometimes it's label, sometimes it's content, but it's always one string prop that you put onto the button. And again, great. We get this design. You want to send the message. We have a text prop. We pass send message into it. Our CSS makes sure that that text is always styled and on brand and exactly what we expect and everything good, again, until it isn't. Design comes back and says, hey, we want to have a nice loading state where we have italicized text. We have nice little like dot progressions. And now our text prop breaks down. So what do? We might go to design, push back and say, hey, we have to release this feature in a week. We have this current limitation. Is there something that we can do to meet in the middle for the short term? But there's a million reasons why you might not be able to do that. If you can't, that's a bad culture. You should be able to have that collaboration, that communication. But there's a million reasons why you might not feel comfortable going back to design and saying, hey, we can't do this. So you might work remote. You might just go to your room, hunker down and think, okay, maybe I add a loading text prop and add the styles and add the animation in there. Maybe I add button v2 component that supports this prop, and now we have a split within our code base that we now have to migrate away the technical debt of the old button. Maybe I just copy the styles of this button component and make a custom one-off component here. But now we have another split where we have a button that looks like it's the design system button, but it's not. So when we make changes over here, they don't happen down here. There's not really a good way of doing this, and there's a reason why. And I think to actually figure out how we can get out of this mess is to first take a step back and figure out how we got into it. So, philosophic question here. And I'm open to take feedback here, but anyone want to answer? What is a button? What do we think a button is in HTML? Anyone? What is a button? Shout it out. What is a button? From which perspective? Yours. As a developer, we'll go. A button is a way to flag an action in an obvious way to everyone else. Okay. Makes sense. Anyone else? A clickable element. All right, cool. Let's take one more. I'm sorry? Beautiful. We didn't plan that. This is perfect. That's what I'm talking about. How I see a button is nothing more than a semantic, interactive container. A semantic, interactive container. Semantic, because it communicates to assistive technologies what this element is, why it is, how it is, what it does. Interactive, because you get that keyboard support, you get the tab stops, you get all that interaction. Container, because HTML does not care what you put inside of that button. You can put anything you want inside of that button. You shouldn't, but you can, and that's the beauty of HTML. It gives you just enough flexibility to shoot yourself in the foot. But HTML itself, the button element in HTML, allows you to pass content into its container because it's nothing more than just a semantic, interactive container. So when we're building components that are abstractions of native HTML elements this way, we want to make sure we're following those same conventions. And in this case, that would mean being able to support passing children into our button. So again, I'm a new developer joining a code base. I try to use the button, and my instinct is that this button will work like it does in HTML and that I can just pass children into the button itself. When I'm able to do that, we're able to keep that knowledge of HTML, and that learning curve of using our components is much easier and much more natural. If we have that text prop, we're breaking that native HTML convention, and that's one more nuance now that we have to remake, and that I, as a developer, then have to relearn. So when we follow the native HTML conventions, in this case of a button and just being a semantic interactive container, we're able to put whatever content we want in here. We're able to now achieve this design. Everyone's happy. But this does go back to the point we want to make sure that we're communicating and collaborating across teams. This requires trust that design isn't going to put anything wonky in the button. This requires trust that developers aren't going to code the content of the button in a weird way. This requires trust that our styles will be able to support the content in there to keep them on brand. Now, I said that the text prop on the button was probably top 3 most common issue I would find coming into a code base. This one may be a little bit more subtle, but top 5 most common. And we have the onChange event handler here for our input. Now, our onChange event handler here, by default, is just going to pass us the value of the onChange event. 7 times out of 10, that's all we need. We were just going to type event.target.value anyway. But those other 3 times, what do we do now? Those other 3 times, what do we do? Again, maybe we go into this interface and say that the onChange may pass either a value of a string or an event of the full event object. But now we have to go through the entire code base, and every time that we're using this, we have to make sure that it is a string, like cast it as a string to make sure that there's no TypeScript errors. It becomes kind of difficult to manage. Maybe we go input v2 again, maybe we do a custom one-off again. And the reason we're having this issue is because, again, we deviated from the natural or native experience of working with events in JavaScript. The native events in JavaScript will send you the full event, not just the value. So you're used to typing event.target.value. But if I come into this code base, try to use the input, and try to have a callback on the onChange event handler, and I'm not getting the full event, it's going to be a thing that I have to relearn, a nuance that I have to relearn, and doesn't feel like the native experience of dealing with events. So again, we can leverage TypeScript to extend the native HTML attributes and functionality of these events. So now, 7 times out of 10, I may just type event.target.value, handle that, and be fine. But those other 3 times, now I can comfortably be able to grab items off the class list. I can grab siblings. I can get the actual key code that was pressed because I have access to the full event as expected as the native JavaScript events are handled. So those are our 3 keys that we want to look at for TypeScript interface management. I think all 3 of these keys can be combined together into one code base, into one set of conventions, and really alleviate a lot of painful interface bad practices that tend to break down over time. So with these keys, we can tend to say goodbye now to a lot of complicated interfaces that tend to break down, that become difficult to manage. We can just say goodbye to them. Or I guess, sticking on brand, we can say bye to them. You can cover the man in tattoos, but you cannot hide the love of boy bands. So those are our interface management techniques. Like I said, if you download the slides, you're going to get one extra one bonus. But that does bring us to our one React key that we're going to look at today, which is going to be component stores. Now, this is something that I learned about maybe just a couple of years ago through a component library called Aria Kit. There's also a component library called React Aria. It gets confusing for me. But Aria Kit. I don't think they were the first people to ever do this, but they're the first ones I saw do it, and it was a quite interesting idea. Component stores in React allow us to keep one component in sync across multiple parts of our UI and our code base. Because just because something in our UI might look like it's one thing doesn't mean that in the code base it's one thing. We might have separate files for one part of a component and another file for another. How I like to use this approach is with the popover menu. Now in this case, we just have a round little hamburger button. That's all fine. The popover menu can open on either side of it. But this is, in my experience, a component that tends to be broken into two places, where we tend to have some type of trigger, some type of button. Could be a hamburger button, could be an icon button, could be a full button, could be a little tooltip, something like that. And then the popover menu itself tends to live in a separate file somewhere else. But with the component store approach, we're able to use a hook in React. And in this case, we're going to call this hook use popover menu. And from this hook, we're going to return a store object. And now that store object, we're able to pass to the button that will trigger the popover menu. And we're able to pass that same store to the popover menu itself. So even though we have two components, they're all using the same store object. So we're able to keep those two places in the UI and in our code in sync. How this will look, can look, may look, whatever. We have a use popover menu hook. And now inside of this, we might do things like handle the keyboard navigation to make sure that once you open the popover menu, focus goes to the first item. You can have keyboard support. You hit escape to close, your focus goes back to the trigger element. Right? We can handle all of that functionality in here. But what we can also manage is the open state of the popover menu. We can create a ref for that trigger element for the popover menu as well. And then with these items created and defined within the hook, we're able to return those as a store object. Now, personal preference, I like to split these into actions and state, just so when I'm using them, to me, it feels a bit clear as to what I'm doing. It's not just one long object of keys, but it's kind of broken up. That's just a personal preference. That's just the way I like to approach it. So we create all this functionality, all these values, and then we export them as a single store object. Now, how does this look in practice? So if we look in the React, I know this is a lot. We're going to break this down. First example here, we're going to create a const of store, where we just instantiate the hook, and we get that store object back. So in this case, store now contains our object of actions and state. We have our icon button, and to the onClick event handler, we're going to pass in store.actions.open. Maybe you want to do this as toggle, but we're setting the onClick to the store's actions of opening the popover menu. But then we also set the ref of this button to the trigger ref within the hook itself. So now when we have this ref defined in the hook, we can do things like add IDs, add ARIA associations between the button and the popover menu itself. We can offload that accessibility requirement into the hook, and all we have to do on the implementation side is just pass in the ref. And I think that is one great key of component libraries and design systems like this is it shouldn't be expected that every single developer is an accessibility guru, that is an accessibility expert. So if we can offload, in this case, those accessibility requirements into the hook itself, the developer just implementing this popover menu doesn't have to think about it, but they get it for free. So we pass in the onClick and the ref to our icon button, which points to our store. And then in our popover menu component itself, we pass in the whole store object. So now the popover menu has access to whether it's open or closed, what is its trigger element, which will help with positioning and placement and stuff like that. And now we have a button and a popover menu in different parts of our UI, different parts of our code base that all reference the same store, and we can keep them in sync using that same store object. But you can also use the hook, in this case, as the entry point for your component. The whole last section, we are looking at putting props directly onto a component. But I like to use the hook, in this case, of use popover menu as the entry point for this. So in this case, we can extend that use popover menu hook with props like an onClose or onOpen callback. We can add a placement prop as well. So we pass all of this functionality into the use popover menu hook, and we can handle all that logic required to support that. But still, on the implementation side, we just pass an onClick, a ref, and the store, and we work everything off of just that one store object. And it doesn't matter if that trigger button changes. Doesn't matter if that trigger button's in a different part of the code base. Doesn't matter wherever that popover menu is. we have one shared store object that we can pass between the two and keep everything in sync with the accessibility requirements baked in. So that's our React convention. We want to do a quick recap just to hit the key points once more. We have our interface management. We have our 3 keys there. And yeah, the one component store convention. But you can read that. I don't need to read it out. The one thing I do want to stress again, I mentioned it a couple times, is that we're not just building components here. We're very much trying to build trust. There needs to be trust between teams, that what is designed is what's developed, that what is the main problem that the product owner is trying to push down is what's being designed, is what's being developed, is that what's actually sent and received and used by the people using your product. We're building trust throughout a product. We're building trust across teams. We're building trust throughout an organization. We're talking about buttons and inputs, and these things by themselves don't matter. But what matters is the communication and the collaboration and the trust that they foster. And one last thing, a disclaimer, we're all developers. Our buttons are always the most special buttons to ever button. Like I said, I think all of these keys can live together and be used simultaneously in one code base, in one set of conventions. But it doesn't mean that they have to in every instance. Your instance might be a little bit different. So it depends. Our favorite phrase, it depends. Like I said, I think all these things work together. You might think differently. Your use case might have different requirements. It's fine. It depends. Use what you wish, use what you may, use what you like, use what works. And with that, I would like to say thank you so much for your time. I super appreciate it. Thank you.